Hello class, I'm working out of your Fundamentals of Math book 4.2, Equivalent Fractions. To get started, we will be given an expression across the equal sign, such as 3/4 equals n over 20. We have 3 of the 4 parts of information, and we are being asked to solve for n. So if we think about this idea, we know that 4 times something will equal 20 in the denominator, and we know that 4 times 5 equals 20 in the denominator to get there. Remember that 5 over 5 would equal 1, and if we multiply the denominator by a number, we need to multiply the numerator by the exact same number to retain the identity and value of the original fraction. So let's take the numerator times 5 as well. That would be like taking 3/4 times 1, but for the purpose of our problem, we need everything times 5/5 on that side of the equal sign. 3 times 5 equals 15. Another example, 30/42 equals 5 over n. Here we notice to get from 30 to 5 we divide. We need to divide by 6. 30 divided by 6 is 5. 6 over 6 equals 1. Whatever we divide the numerator by in value is what we need to also divide the denominator by. 42 divided by 6 equals 7. So our variable n equals 7. To solve a problem such as this with cross multiplication, we can set our cross multiplication equal to each other. We're going to multiply in 4/6 equals n over 15, 4 times 15 first. That would be equal to 6 times n. 4 times 15. We know that is 60. Which equals 6n. Go up here. If we have 60 equals 6n, 6 times n. To solve algebraically, if 6 is multiplied by n, then we divide by 6 on both sides. 6 over 6 is 1. N is left by itself, which is our goal. 60 divided by 6 is 10. N equals 10 in cross multiplication. When will you need cross multiplication versus multiplying or dividing by a fraction that equals 1? Follow your instructions to decide that. Always follow instructions. Alright, in another example, if we are asked to find an expression's solution such as 3 plus 9 in the numerator, 8 minus 6 in the denominator, all times 5, plus 7 times 3, let's consider gems. This is up in the room. We've talked about it a little tiny bit. G means grouping, E means exponents, M means multiplication and division, S means subtraction and addition. We address the order of operations in this order by math rules. So let's look at our expression. We see we have multiplication on this side of the addition sign, and we see we have multiplication on that side of the addition sign. We also have some division simplification in our fraction. We can work with that as well. So just breaking this down, we know 3 plus 9 in the numerator. We're going to rename that as 12. We know 8 minus 6 in the denominator. We're going to break that down as 2. And we only worked with that part of the expression. Okay, so we know 12 divided by 2 is 6. And we're just going to rewrite times 5 plus 7 times 3 to keep simplifying. Next slide. Just rewriting our expression. Let's rename 6 times 5. 30. Plus, come straight down, rename our grouping for 7 times 3, 21. And we have an old-fashioned addition problem. 30 plus 21 is 51. Working in GEMS. Let's go back over that. We were given an expression. We could first simplify what's in the numerator and denominator with addition and subtraction because it's part of that fraction. After we grouped on either side of the addition sign, look that over. And then we start simplifying. We keep carrying down every part of the given expression that we don't work with in the next line. This is where showing your work is super important. You're going to use a few lines of your paper to properly work out a problem such as this. When we simplified all the way, we had 2 groupings. We do multiplication before addition, so we multiplied the first grouping, added the second grouping that is multiplied, and we get down to just basic addition at the end, and we solve for the solution 51. Here's another example. If we are asked to simplify 29 minus 7 times 6 in the numerator over 4 minus 1 in the denominator. Okay, let's look. Let's just simplify what we know in our numerator and denominator, rewrite everything else out. And we're going to address that later. 7 times 6, that's 42. 4 minus 1, that's 3. All right, 42 divided by 3. We can rename that in our next simplification. On our next line, it's going to be 14. Rewrite everything in the expression above before that as given. Now we have simplified to a basic subtraction problem. We can solve 15. Another example, 5 plus 3 times 7, all over 9 plus 4. All right, we're going to think GEMS. Here we don't exactly have groupings, but we do have multiplication and division before we add information. So to do this, we're going to say we need to multiply our 2 terms in our numerator first that are sitting there and just repeat everything we see around it. 5 plus 3 times 7 would be 21. All over 9 plus 4, we can do that real quick. That's 13. All right, 5 plus 21 is 26, all over 13. And we've simplified to an improper fraction, and 26 divided by 13 is 2 in our final solution. I hope this helps, and I'll see you soon.